This is
physics! Our first task in analyzing the physics of 300 was to determine if it was physically possible for a human to throw a spear as Leonidas does when he hits Xerxes in the side of the base. First, we estimated the parameters of the spear throw, determining that the spear had a 3-meter displacement in the y direction, since it began 2 meters off the ground in Leonidas' hand and ended uncomfortably close to Xerxes' head, 5 meters off the ground. We also determined that the time it took the spear to reach Xerxes was roughly 2 seconds. The acceleration of the spear in the y direction was negative 9.8 meters per second squared, since it was on Earth and the only force acting on the spear while it was in the air was that of its weight, assuming no air resistance. We wished to know the initial y velocity, and we didn't need to know the final y velocity. Armed with this information, we set out on our glorious mission.
Yeah. Anyway, first we plugged our numbers into a kinematic equation which yielded 11.3 meters per second as the initial y velocity. Using basic trig knowledge, we knew the sine theta of the throw multiplied by the total initial velocity would yield the initial y velocity. So, we plugged in the initial y velocity and the angle to get a total initial velocity of 26.7 meters per second. After this, we determined the change in momentum for the spear. Using initial momentum of 0 and assuming the mass of the spear to be 14 kilograms, we found the change in momentum to be a whopping 374.3 kilogram meters per second. Knowing this, we took the task of this massive spear throw into our own hands.
The epic spear throw.
King Leonidas runs towards his weapon. He finds his weapon of choice, his spear. He turns to face the Persian king, Xerxes. He stares, he's running, and he screams with a ferocious yell, and he throws the spear. Now, it is our turn to attempt this. This is by far my best throw. I wouldn't be so lucky later on. Hey, look! Oh, there's not supposed to be trees in 300. Practicing form, using shoes as efficient measuring tools, it's all good. See, that time, not so much. Let's see Joseph. A little farther, a little better. Oh, look, Mr. Professional here. Look, I can throw really far. Stupid lefty. Now I'm trying to beat him. I just did worse than before. Interesting. As the night went on, skills progressively got worse. This is where Tristan pressures Joe, Joe gets scared, and performs poorly. Observe. He seems scared, timid. He throws the spear, not very far. Of course, when you take into all accounts of all the other spear throws, at least his was better than Tristan's, as you will now clearly see after Cody's done. Dead. As you can see, we were not able to do as well. Using similar methods of throwing, but with a spear weighing much less, we were still able to calculate the change in momentum. Our change in momentum with a 1 kilogram spear and an average velocity of 13.5 meters per second was 13.5 kilogram meters per second. As you can see up above, next to the Leonidas head, he was able to attain 374.3 kilogram meters per second. Ours is significantly less. Using the FADAP equation, and assuming that delta T was roughly the same for all spear throws, force would be proportional to change in momentum. Although we were not able to come close to his numbers, King Leonidas also has years of training, much stronger than we are, had an actual spear, and don't forget, he's a Spartan. So it is quite possible he could have done this. Now, for our next problem. Let's see what happens when a messenger asks King Leonidas for earth and water.
madman. You're a madman.
Yeah, and water. But you'll find plenty of both down there.
No man, Persian or Greek, no man threatens a messenger.
You bring the crowns and heads of conquered kings to my city steps. You insult my queen. You threaten my people with slavery and death. Oh, I've chosen my words carefully, Persian. Perhaps you should have done the same.
This is blasphemy. This is madness.
Madness. This is Sparta!
Okay, so, here we go. Our next problem of the day is to determine how long it would take the Persian emissary to reach terminal velocity after King Leonidas kicks him into the pit of doom. After determining terminal velocity for humans is 53.6 meters per second, thank you Google, we used a kinematic equation and solved for time. We determined that we didn't care about displacement since the emissary was going to die anyway. Yeah, I know. Sucks, right? The velocity initial in the y is 0 meters per second. His velocity final is
Negative.
53.6 meters per second, and his acceleration is negative 9.8 meters per second squared. Yet again, time is what we were solving for. After plugging the numbers into the equation, we got 5.41 seconds.
This is madness.
Madness. This is Sparta! Madness!